In 2013, a tornado larger than Manhattan appeared over Oklahoma. At first, it looked ordinary, just another storm forming above Tornado Alley. But within minutes, meteorologists realized they were looking at something impossible. This was not just another tornado. It was a storm so massive, so unpredictable, that it rewrote the laws scientists trusted for decades. And before the night was over, it would kill the very experts trying to understand it. Even today, scientists still cannot fully explain what happened inside that storm. This is Infinite Enigma X. The afternoon of May 31st, 2013, began quietly. Warm air drifted across the Oklahoma plains. The skies looked calm, peaceful even, but hidden above the atmosphere. The ingredients for disaster were already forming. Oklahoma sits directly inside Tornado Alley, one of the most dangerous weather corridors on Earth. Every year, warm, moist air from the Gulf of Mexico collides with cold, dry air descending from the Rocky Mountains. And when those air masses collide violently enough, the atmosphere begins to rotate. That rotation can become deadly. Meteorologists watching radar systems that afternoon immediately noticed something disturbing. The instability levels inside the atmosphere were extreme, even by Oklahoma standards. CAPE values, the measurement used to calculate atmospheric energy, had climbed beyond 5,000 joules per kilogram. For comparison, a severe thunderstorm can form at less than half that energy. The atmosphere above Reno had effectively become a loaded weapon waiting for a trigger, and shortly before evening, that trigger arrived. A cold front moving from the northwest collided with warm, unstable air rising from the south. At the same time, powerful winds high above the atmosphere began shifting direction violently with altitude. Meteorologists call this wind shear, and under the right conditions, wind shear can tilt invisible horizontal rotation vertically into the sky. That transformation creates one of nature's most dangerous phenomena, a supercell thunderstorm, the king of storms. Supercells are different from ordinary storms. They rotate persistently, violently, and sometimes they produce tornadoes powerful enough to erase entire towns. But what formed near Reno that evening was not behaving normally. Even experienced meteorologists began struggling to understand what they were seeing on radar. Because instead of descending slowly from the clouds, the circulation appeared to be strengthening near the ground first. The tornado seemed to be building upward, not downward. And that single detail would later change tornado science forever. It wasn't supposed to behave like this. For decades, scientists believed tornadoes formed from the clouds downward, but Reno appeared to do the exact opposite, and that terrified meteorologists. At 6:03 p.m., the tornado touched the ground southwest of Reno. At first, it looked small, almost harmless. Just a narrow funnel beneath a dark, rotating cloud. For people living in Oklahoma, it barely looked unusual. But radar systems were already detecting something horrifying hidden inside the storm. The circulation near the surface was strengthening at impossible speed, and within minutes, the tornado began expanding, fast, far too fast. Most tornadoes grow gradually. Reno did the opposite. In less than 60 seconds, the tornado exploded outward into a gigantic wedge. The rotating winds stretched more than 4.2 kilometers wide, wider than Manhattan, wider than the visible horizon for some observers, and suddenly, people could no longer recognize where the tornado actually was. That became the deadliest part of the storm, because this no longer looked like a funnel cloud to anyone driving nearby. It looked like darkness itself moving across the plains. Inside the tornado, something even more terrifying was happening. The Reno tornado was no longer a single vortex. It had transformed into a multiple vortex tornado. Smaller tornadoes, violently rotating around the main circulation. A storm within a storm. Mobile Doppler radars deployed near the tornado recorded wind speeds approaching 480 kilometers per hour. Some scientists believe certain subvortices may have exceeded 500 kilometers per hour between radar scans, among the fastest winds ever recorded on Earth. But the true horror was not only the speed, it was the movement. These subvortices could suddenly accelerate sideways across the ground at racing car speeds. One moment they appeared distant. Seconds later, they could be directly beside you, invisible behind curtains of rain. Even experienced storm chasers struggled to understand what they were seeing. and some of them were already trapped inside it. This was no longer a tornado. It had become something chaotic, something meteorologists had never fully witnessed before. And somewhere inside that storm, scientists were driving directly toward it. One of the vehicles chasing the storm that evening belonged to legendary tornado researcher Tim Samaras. Unlike many storm chasers online today, Tim was not chasing adrenaline, he was chasing data. For years, he had dedicated his life to studying tornadoes scientifically, designing specialized probes, tracking storm pressure, measuring near-surface winds, trying to understand how these monsters truly behaved. And among meteorologists, Tim was respected as one of the safest storm researchers in the world. That's what made what happened next so terrifying. At approximately 6:20 p.m., Tim and his team were driving along a gravel road south of Reno, parallel to the tornado. At least, that's what they believed. But the storm was changing shape too quickly. The rain wrapping around the tornado made the true edge of the circulation almost impossible to see, and suddenly, the clear air around them vanished. Tim reportedly transmitted one final warning over radio communication. "There's no rain here. We're in a bad spot." Those words would become infamous inside the storm-chasing community, because seconds later, the tornado changed direction. The storm turned, and when it turned, the scientists realized they were no longer chasing the tornado. The tornado was chasing them. A violent subvortex suddenly accelerated around the southern edge of the main tornado. Radar later estimated wind speeds near 320 kilometers per hour. The subvortex struck Tim Samaras's vehicle directly. The car was lifted, thrown hundreds of meters, and completely destroyed. Tim Samaras, his son Paul, and meteorologist Carl Jung were killed instantly. For the first time in history, professional storm chasers had been killed by the very phenomenon they spent their lives studying. The news sent shockwaves through the meteorological community, because if Tim Samaras, one of the most experienced tornado researchers alive, could be caught off guard, then nobody was truly safe near storms like Reno. Nature had broken the rules again. Even today, the Reno tornado remains controversial. Officially, it was rated only EF3 on the enhanced Fujita scale, not because the winds were weak, but because the tornado avoided major populated areas. The rating system depends heavily on visible structural damage, and most of Reno's strongest winds crossed open fields instead of cities. But mobile radar systems measured winds exceeding 480 kilometers per hour, strong enough to qualify as an EF5 tornado, the most violent classification possible, and many meteorologists still believe Reno may have been one of the strongest tornadoes ever recorded, a monster hidden in plain sight. More importantly, Reno forced scientists to rethink how tornadoes form entirely, because the storm appeared to build from the ground upward, not from the clouds downward as traditional meteorology predicted, and that discovery may permanently change tornado forecasting forever. The Reno tornado was not just the largest tornado in recorded history, it was something far more unsettling, a storm so chaotic, so unpredictable, that even the scientists studying it could not fully understand what they were seeing until it was too late. For decades, humanity believed tornadoes followed predictable rules. Reno shattered that illusion, because sometimes nature does not care about our models, our radar systems, or our confidence. The atmosphere still hides mysteries we do not fully understand, and somewhere above the Oklahoma plains, those winds reminded humanity of something terrifying. The planet beneath our feet is still wild. This is Infinite Enigma X, and some of the most dangerous discoveries are the ones hidden inside the storms we thought we understood.